Hello everyone, and welcome to this webinar about how to challenge the large scanning market at the cost of consumer-grade tools, combined with a little bit of artificial intelligence and your photogrammetric software. My name is Emanuele Traversari. I am a global geospatial expert and business advisor for drone application and technology. Proud to lead the mentoring program at the Drone to Business, a service platform where we mentor drone professionals to become unique in the market, optimizing activities and implementing profitability. That's it. I want to thank GeoIgnite 2020, the team, the organization, the organizer, for the kind invitation and for the opportunity to share with you my challenging presentation. Thanks to all of you for having reserved almost an hour of your valuable time to attend this session. It is recorded, but we will be running a live Q&A session at the end. So I encourage you to pop your question on the dedicated section of Zoom. Before starting, let me thank God. Since we are here in this difficult moment of pandemic, when maybe you, like me, have lost somebody in the family due to the coronavirus and may facing big difficulties in business. But today we are here, healthy, so we can look at the glass as a half full, and we can move forward, evaluating opportunities that could lead to a better situation. And today, I want to challenge photogrammetry to get down to 1 millimeter accuracy, and not using revolutionary equipment, maybe very expensive, but simple consumer-grade tools and the software we normally use. To do this, I have the valuable support of Carlos Maya. Carlos is a photogrammetric expert specialized in aerotriangulation. He's a globetrotter, originally Brazilian, and he gained his skill and knowledge at the ITC in Holland and at the University of Stuttgart in Germany. Today he lives in Canada, and it is my privilege and honor to have him here today on board now to introduce and clarify the concept behind the challenge. Hello, Carlos. Now the ball is going into your field. Let's go.
Hello, Emmanuel. How are you doing? Thank you very much for your nice words. To me, it's also a pleasure to work with you. You are alumni from ITC Holland as well. You are currently a brand ambassador of an acclaimed photogrammetric software, and you're teaching about it on Switzerland, Italy, and Brazil. And also, you're right. Having the opportunity to study and work under those gurus who wrote the modern photogrammetry was a privilege. Such a privilege allowed me to be part of two pioneers group in Brazil, one with the Brazilian Army Cartographic Branch and the second one at the Brazilian Space Institute. I also worked with the Brazilian government civil mapping branch. That was before coming to Canada. And thanking to GeoIgnite, we have this opportunity to share our experience with the Canadian geometric community. So let's talk about our subject, expecting an accuracy of 1, 2, or 3 ground sample distance in our project. Do you know where it comes from? I'll give you some highlights. There are two main phases. One is data acquisition, and the second one is data processing. With data acquisition, we have to know the camera and we have to plan our flight. With relation to the camera, the focal length and the angle of the field of view angle is very important. It will reflect on the point on the ground, the B here. If we have a long focal length, so this angle will be narrowed, and projecting rays that come from overlapping photos will tend, well, let's say like that, will tend to be intersect on a small segment of line. If we shorten the focal length, then the field of view will be wider, and then the coming rays will tends to intersect in a cross, and then or in a point. That is the best situation for determining it. Still about the camera, we have to talk about, it's important to talk about the sensor size, okay? An example, if you have a camera on the smartphone, then you have a handheld camera, the sensor size are very different very different, and the image on the handheld camera will be more, it will have better resolution because the size and the size of the pixel itself. It will be, so we're going to receive more lights and we will be more reliable in terms of the measurements, so we have more accuracy. And up here, if we have the same situation, if you lower or if you put our airplane higher, so there will be an influence as well on the angle of view and on the projection of the pixel on the ground. This is the flight height. The second phase, or the second important step, is rely on the measurements and assure redundancy. So on this graph here, the green area is the one which defines the sigma 1 or sigma naught. So all the measurements within this 68% are in a good stand in terms of measurement. If it tends to go into the blue areas, then it starts to be a blunder or outlier. And of course, if it's on the pink area, then definitely will be a blunder, and it has to be detected and eliminated. How do you do this? How do you detect and eliminate? By redundant measurements. So the redundancies you see here, that's this little point, this top of this little tower here, is image in several photographs, as the rays will show. This is possible due to bigger overlaps or cross strips or cross flights. And of course, if there is one measuring error, so we will be able to detect it very easily because we have more rays coming into. What's accuracy anyways? Well, if you have a metric measuring tape, and the accuracy of this will be how exactly or how absolutely the measurement you do with this tape is representative for the standard meter, which is exposed at the International Bureau of Weights and Measures. So this is the essence of accuracy. The absolutely of it. Importance for high accuracy, the volume evaluation example. We talked about that. So we have a 200 by 200 by 10 meter pile. So the volume will be 400,000 cubic meters. if we do a measurement, accurate measurement, figure out that the height is not 10 but 10,001 millimeter, then the change on the volume by 40 cubic meters. So what do we do with this extra 40 cubic meters? If we detect it by our accurate measure, then we're going to make money. Yeah, if we detect before we move or we sell the pipe. If you don't detect that, if you don't use the accurate measure, you don't detect that, we're going to lose money in this case. Also to consider is with the extra volume, whether we're going to have to move it, how many truckloads of moving or selling or whatever business we have to do with this. So every millimeter represents money, okay, either negative or positive. And this is what the information I had for you today. And from here on, we go with Emmanuel. He's going to give you more details on the millimeter level of accuracy. So go ahead, Emmanuel. It's with you now.
Thank you, Carlos. You have given us such a clear introduction. In such a limited amount of time, we have learned about the elements that are influencing the quality of a photogrammetric work. Elements that are anyhow valid, either when we collect images using an airborne system or drones. I like it. I like it. Even to review all arguments that are also content of our training activities and master classes at Drone to Business, where we train and coach a drone professional to get all that in a clear workflow and use it in their daily activity with a guaranteed quality and productivity and profit. Anyhow, the challenge of today is to use a photogrammetry system to get similar results as a LiDAR equipment can achieve with accuracy down to a millimeter. The reason is clear. We can equip our drone with a LiDAR system to get very precise data and very detailed 3D point cloud representing our ground or our subject. But the required value for the investment is high. We are talking about $100,000 just to start. And not all projects can give the proper return of investment, especially in niche markets where we have small areas or small targets. On the other hand, the amount of money to invest for a drone or for an equipment to support a photogrammetric workflow is much lower, at least half of the LiDAR. We can get anyhow reliable data and 3D point cloud, but we have to face the rules of photogrammetry that Carlos just explained. The rule of thumb, remember? Therefore, let's take a step forward, have a tool set, a set of modern tools consisting of consumer-grade equipment, apply with artificial intelligence approach and algorithm, all for automating 1 millimeter measurement accuracy in photogrammetry survey. Reaching sub-centimeters accuracy is not that easy. We have to care about quality in all details. When talking about quality, we are talking about degree of excellence of either a product or a service. A photogrammetric project is based on a workflow made of several different operations. Sometimes different operations executed by different specialists. The surveyor works in the field, but maybe he doesn't take images. And often the drone pilot is not the person who does the data processing. Therefore, To challenge our excellence, we should care of each single detail included in our photogrammetric workflow. In quality assurance, we know that each element of each single operation influences the process and the final results, don't we? In photogrammetry, we want to achieve two goals. Reconstruct a 3D object from images, of course, a 3D object that should be accurate when comparing features within the reconstruction, the so-called relative accuracy. For example, if a model of a building shows windows 2 meters apart along a flat wall, and this is the same distance and flatness on the actual building, the model has a high relative accuracy. The second goal is to put the reconstruction in the correct place and in correct 3D scale comparing to the real world, the so-called absolute accuracy. For example, this house can have a high relative accuracy as it has been correctly reconstructed, but a low absolute accuracy as it could be in the wrong place in the reality. The solution we are presenting you today is based on a few ingredients. The most important are the calibrated photogrammetric tags produced by Reko in Germany. The concept starts from the design of the tags, made of an optimized surface material to enable the surveyor to mimic measurement standard conditions, the conditions he could get in a laboratory, now in the field, to systematically achieve sub-centimeter measurement accuracy. Then go further with a full control of photogrammetry techniques supported by artificial intelligence. So let's summarize what we are going to use. Measurement units, that includes photogrammetric tags, okay. Then consumer-grade equipment, consumer-grade cameras, easy operation, artificial intelligence algorithm, and off-the-shelf photogrammetry data processing software, Pix4D. We use a Pix4D mapper module, very, very suitable for the tasks. Nevertheless, later we're going to call it anyhow, shortly, Pix4D. What we want to achieve is to generate systematically automated precision in photogrammetry workflows. To be able to trust our final results, two issues have been implemented: the photogrammetric tags and a suitable measuring device. The concept of tags to calibrate the model, along with the usage of GCP markers to orient a project, are pretty common to surveyors. Nevertheless, here we are entering the sub-centimeter accuracy world, where the tags are implemented to guarantee in the field not only the typical orientation parameters, but also measurement standard conditions very close to what we usually have in laboratory to calibrate systems. They are unique, made of unique material to guarantee the previous mentioned relative and absolute accuracy. They have a unique shape and a unique code, different size, and even 3D forms. And they can be placed anywhere in your model, regardless of their orientation, since the artificial intelligence algorithm will care about that. The coded targets are then used for automating the photogrammetric workflow and provide a lot of benefits. Well, automatically generate type points, automatically locate ground control points, reduce time for manual measuring processing steps, and seamlessly merge sub-projects. Then, last but not least, they are automatically detected and registered within the photogrammetric software. What are the possible purposes of this solution? Well, close-range application, we have a model of a stone wall where we had the goal of finding the combined stones that provide the mechanical stabilization of such a wall, the single stone that traverse both sides of the wall, preventing the wall to collapse over time. Inspection, we challenge a photogrammetric inspection of a dam as a part of a renovation project. The four main aspects you must consider in order to obtain a photogrammetry model where we can perform down to millimeter accuracy measurements are to know your camera, to trust your measurement, control your space, and understand how your photogrammetry software works. And here, Pix4D users are going to learn interesting tips and tricks. So let's have a look at our example, the stone wall. The main input for any photogrammetry survey and inspection are images. In this case, we have a result based on standard RGB imagery from a consumer camera. So we need to know our camera, and we have learned from Carlos that the camera properties, as well as the image distance from the object, are the key factors in computing the GSD. With this parameter defined, it is possible to calculate the GSD with a clear common formula. We should use the same formula for the sensor height and the sensor width. And in common practice, we usually select the highest of the two values for determining the GSD. In this project, we use a consumer-grade Sony A5000 camera with an APS-C sensor and a 10mm lens. It is a good camera. It's good for photogrammetry application, as we can see from the corresponding properties. Using the calculation from above, we can estimate that a maximum distance of 2.3 meters from the object is required to maintain a GSD of 1 millimeter. And in this way, the images have been taken directly in the field. So to verify, let's go further looking at verification of the measurement of the real world. That is very challenging for human beings, especially as the measurements get smaller across larger spaces. For this reason, to precisely measure the world around us, we rely on certified equipment like total station, laser scanner, or laser distance measurement tools. For this work, we use Leica Disto 810. These kind of devices are certified for accuracy. Nevertheless, as users, we still have the responsibility to maintain the required conditions while we apply the proper technique in the field. The calibration certificate we got from Leica showed that a target plate albedo 1 was used to calibrate the device. It is a kind of target able to reflect all incident radiation, then calibrate the disto at its best, down to our 1 millimeter accuracy. And this is now the base element to construct the measurement system of our wall project. It is in the model space where all issues, difficulties, and constraints influencing the photogrammetry results enter into the game. We should try to master them to achieve our goals. The reconstruction of the 3D model depends on the overlap between images, as well as the visual content of the images. And sometimes are images of a subject that is not optimal for pulling precise measurements due to material of the surfaces, shapes, or inaccessibility. The challenge of collecting images is to record the ideal situation. However, in our case, for sub-centimeter ground sample distance projects, it is harder to get the ideal conditions. Problems such perspective, vibration of the camera, blurring, depth of field, the type of shutter, all these issues are magnified, introducing errors that influence the relative accuracy. Funny to say that this error is not global. Some areas will be more accurate than others due to local influence or all above mentioned elements, of course, but also how close they are to tie points that we introduce and measure manually. By implementing coded targets and place them around the infrastructure to be scanned, we create predictable points for pulling precise measurement independent of the condition of the model space. It is the combination of precisely locating all the target corners, or all the coded targets around, and using an optimized surface material for precise measurements with the disto device that enable 1 millimeter accuracy precision for our terrestrial photogrammetry projects. And the points used for measurement are then automatically recognized within the photogrammetry software for model calibration and for model area triangulation. A photogrammetric model of a wall made of stone was constructed with the goal of finding the combined stone that traverse both sides of the wall. First, we had to create an accurate model of the structure, and secondly, we created the calibrated mirrored orthophotos of the two sides in order to see through the wall and determine which stones traverse the entire structure. We have distributed the tags in the key position, a lot of 3D tags on top of the wall in order to precisely combine later the two sub-projects. And once the images were taken and the field measurement with the distos completed, we entered the processing workflow in the office. We went back to the office, we start our processing workflow, and that is pretty straight and automatic, leaving the operator the only duty to check the quality and the results, of course. The artificial intelligent target, it is an algorithm that scans all images to identify the coded tags, and it records their XY position from each image. The results are written in output file that will be used as an input in the Pix4D software before processing. In Pix4D, we can create a new project and define all parameters as usual. From create a new project, select the images, define coordinates, pick up the processing template till when the map view opens. Pix4D user know what I'm talking about. It is the same as always in Pix4D Mapper. It is the ground control point manager. It is there where we define our tags and eventually the ground control point, if we have any. Then we run through the usual step one to get the processing, we evaluate the quality report, and if accepted, we go through, we go further, and we can make all the following processing step to generate the dense cloud and the 3D mesh. And these are the hidden tools, the artificial intelligence algorithm, the target. It is the one that scans the images to find the coded tags and create the file for Pix4D to know the location of those tags in the images and to know their unique codes to position them and use it for georeferencing. And in Pix4D, we have the function to import mask to get those tags directly in the image space of Pix4D. I guess a function not much used for most of the Pix4D users, isn't it? I would love to have a feedback from you. if anybody is using it, even for other purposes, may write in the Q&A session or directly leave a comment in my LinkedIn profile. After initial processing, your tags are already present within the model, and the quality report of your photogrammetry model shows the errors of the compiled length measurement and scales constraints. In our situation, we are down to millimeter in all constraints. Very good result. Worth to say that is also scalable. If you are a surveyor, you may have already a total station, a GPS receiver. Therefore, instead of the disto, you can use that equipment to measure your tag and use them as a constraints in your model. The results are clean and great. A 3D model with a high relative accuracy and absolute accuracy suitable to find the stones and define all the shapes for the reconstruction with a millimeter accuracy. The same workflow has been implemented in other projects of different size to evaluate small measurement in larger spaces. The inspection of a dam, here we have, here the final result of a photogrammetry model within Pix4D. All green control points were automatically detected using the coded targets, and the measuring accuracy was down to 1.2 millimeter. Here we are. I'm confident we achieved our goals. We challenged the laser scanning market at the cost of simple tools combined with artificial intelligence and Pix4D processing software, a well-known photogrammetry software well suitable for the tasks. Actually, the challenge got a higher benefit: define highly accurate photogrammetry processing fully automated at a much lower cost compared to laser scanner and total station. A new solution to operate. And this is part of our challenges at Drone to Business, our unique mentoring platform for drone professionals to get a newer view to the capability of the drone technology to profitably operate in the market. Thank you. Thank you for your patience. I thank you for your attention. It has been an honor to be with you today. I'm confident I've drawn your interest and you have written several questions in the chat section. Therefore, we are looking forward to meet you in the following Q&A live session.
All right. Thank you very much. That was very interesting. And I know that with our speakers right now, we're dealing with a variety of time zones. So thank you both very much for being here. It's very appreciated. And a friendly reminder to all of our attendees to please enter your questions into the Q&A. I see that we have a few coming in. We did receive a quick question in our chat. Just wanting to confirm if the 1 millimeter is relative accuracy, not absolute accuracy. Is that correct?
No.
No? Okay, just that was meant to clarify with him. So
I have a good example for that. Okay, go ahead. Go ahead, Emmanuel.
The system has been implemented with a combination, in this case, where we have our resolution and of the images that creates the relative accuracy at the same level than the absolute. Sorry, should be the other way around. The absolute at the same level of the relative accuracy, and it is an absolute in this case. In this case of the bridge, of the stone wall, we scale the system at 1 millimeter accuracy. That is absolute accuracy.
Okay, wonderful. Our next question is, who sells the cubes? Where can we find the AI Tagger software? Does the software come bundled with the cubes?
This is a combination, is a kind of solution that we promote in our mentoring program at Drone to Business to show the students that there are new challenges, and we do not need to invest a lot in the market. That what is important is to find the right application and have the right capability with the right genius to challenge that market and work. Now, it is a bundle. Actually, Leica Disto is a Leica Disto. We buy from Leica. The software is the Pix4D software produced by Pix4D in Switzerland, and the tags. The tags are different. They start from little small size up to a 50 centimeter side, so a square of 50 by 50. And they are made of a very, very special material that is able to reflect all the incident in order to allow the measurements at its best down to a millimeter as it was in the Distos. They are produced in Germany from a partner company that is Vaireco.
Okay, wonderful. I guess to dive in, I know we've talked a little bit about the software in the back end, but how big are the cubes, how heavy, and approximately how many are needed to cover a large area?
Well, they need to produce it. I can give you the technical specification. Okay, this is a typical, thank you for the question, because actually it highlights a big issue that is always around the market of drones. Like I can do everything. I just need to take a picture. But then they discover that it's very suitable for small area and is not very suitable, at least the way it is nowadays, for large areas. The same apply for these tags. A small tag is very suitable for a small area, like a room or inside photogrammetry reproduction. Larger tag is required for bigger areas. Of course, you cannot map the old Ontario, but it's going to be too big. Maybe you need a satellite images for that. Even a drone is too much. Nevertheless, we are applying for the tags in a size of 50 by 50 that are made in a special material that is an aluminum liga that is that reflects the light and at the same time is not deformed to control automatically dam deformations. That is a project ongoing in Brazil where we automatically surveying the dam to a long period of time to see eventually deformations. And interesting to see that to say that it's not the center of the tag what the software recognizes.
Okay.
Every tag has a unique code. Every unique code has a shape, and the software recognizes shapes. And according to the internal parameter, he gives to the four corners the position. Mm-hmm. And that gives the opportunity that you can place your tags in the model with any kind of orientation. The software does the recognition. Artificial intelligence should be intelligent, no?
Fair enough. All right. We do have a couple of questions coming in regarding training. So asking to elaborate on the training as well as what format is the training for drone professionals in online, in person, webinars, etc.
Well, my big challenge with the help of Carlos, that is a great aerial triangulation professional specialist, was to give it in directly. But then the coronavirus happened and then we are all blocked at home. Why? Because actually training itself, it can be sometimes just a sequence of knowledge to to say click, click, and that's it. This is free of charge in internet. We don't even need to give training. People go around, find the information, but the information itself, most of the time, is just an information. When you start working, you have to build your knowledge on top of the information. And this is the first step that requires more than the simple knowledge. And moreover, especially working in the drone business, I'm dealing with the new generation with a lot of lack of capability to enter the market. There is a big problem. We know the drone is most of the time, oh, very easy. I just fly, and now I'm a specialist. I'm a surveyor, I am a mapping, I am everything. And then the problems start to appear, and the market is rejecting this kind of approach. So we have to create really the genius of the person to apply in a suitable segment of the market that can be anything, because we have 100 of applications of drones in the market. And surveying is the last. Unfortunately, it has been the first, but I hope it's the last.
Carlos, do you have
and today, sorry, I didn't answer the question, bro. Today we do it online. Sorry, we use a live Zoom, of course. We use the transfer of data with the Google Drives or Team, and with the TeamViewer we interact. But as soon as the coronavirus will be over, I really would love to come back to do it presently, because it is with the energy that we have and with the brand knowledge of the market that we, unfortunately, we got a long time we passed in the market, and we learn a lot. And this is what is important to transfer for the person to enter the market and be profitable in a very good and quality way.
Yeah,
I don't know if it was the right English, I hope. Sorry,
yeah.
Carlos.
Yeah, well, no, it's okay. And currently we have a 70 years webinar built. And also, according to the client, we can customize the training. It depends on what they want to do. I see something about forestry, and Emmanuel was talking about very high accuracy on dams and those kinds. So we can customize the training as well on webinars, and furthermore, presently, as Emmanuel mentioned.
Wonderful. All right.
Thank you.
Unfortunately, we are running low on time, so this will be the final question. I do recommend that anybody who has additional questions or any questions we didn't get around to, please use our Slack channel to communicate those questions and get all of those conversations continued. So our final question is, how many AI tags have you used for this project, and how do you decide how many are needed and where to locate them?
The size of the tags, well, no, the number of the tags must be around 25 we place. But as a matter of fact, the most important were the square, the cube on top, because the cube on top were visible from one side and the other side. And when we merged the project, was merging automatically. And nevertheless, if I have just 30 seconds to end, we prepare, Carlos is promoting, we have prepared a specific training that is online, where we enter the mentoring program. You can, if anybody wants, can just search our landing page that is drone2business.com. And there we can get in touch. And it's a landing page, it's not an... So it's to get in touch free, at no cost.
Wonderful. And I will open it up for final remarks from the both of you. Anything you would like to add, Carlos, Emmanuel?
Carlos?
Thank you very much for you guys, for GeoIgnite, Tessa and John. We believe that was a big effort to set it in webinars. And thank you very much for my participation, for my opportunity. And all the best for the future. Thank you.
Thank you, and sorry that you for 30 minutes you have been listening to this strange accent. I'm Italian originally. But thank you very much for your patience, and really thank you for the invitation. Congratulations for all the Gemini team, you, Tessa, John, for what we are doing, because it's a great effort and with a beautiful results that we see. Thank you.
Thank you both so much. And thank you to all of our attendees for partaking in this particular session. We are continuing following our break with our final session in the other Zoom room. So following the session, this Zoom room will close. And that session will be with the president and CEO of PCI Geomatics, and that is June McArley. And the talk is making Earth observation intelligence available to the decision makers that drive our future. So it'll be a very interesting talk, and I hope to see you all there. Thank you again, Emmanuel and Carlos, and enjoy the rest of your day.
Thank you.